Let's talk about storing storage in switches, routers, and things and all. Normally, networking device, there are four types of memories available, starting with flash memory, ROM memory, NVRAM, and RAM. Flash memory means think like your computer hard disk. In computer, we have a hard disk, right? Similar way, it's called flash memory, where your IOS image is storing. IOS means Inter-Network Operating System. See, like in Windows, we have Microsoft OS, Windows OS, we have Mac OS, Android OS, iPhone OS. Like that, we have iOS. It's for routers and devices, Cisco devices. So in flash memory, we store the iOS images and act as a permanent storage for the OS. Second, we have ROM memory, read-only memory. See, when I'm booting my Cisco device, right, my OS, which is in flash memory, need to come and boot in the RAM memory. It has to come and bring up the device itself. Now, this work will be done by read-only memory. This ROM has a program called Bootstrap program, which is going to help iOS image present in the flash memory to load in RAM memory. So that device brings up, come up. NVRAM stores startup configuration, RAM stores running configuration. Running configuration means currently running on my device. It is currently running on my device is termed as your running configuration. Startup configuration means, see, this configuration which is running is currently running. When I'm going to save it permanently, that is termed as your startup configuration. So the command to see running configuration is show running -config. So running configuration means currently running on my device. Startup configuration means the configuration which I saved permanently in NVRAM. Difference between RAM and NVRAM is that RAM means volatile memory. After a physical reboot, whatever information stored in it, it will be lost. NVRAM means non-volatile. If you are saving something in the NVRAM, it will be saved permanently. It is not lost. If you want to. That's called your non-volatile memory. Now, what is the command to see running configuration? The command is show running -config. Command to see startup configuration is what? Show startup -config. Okay. So that's the two different commands. Now, erasing the command. Erasing means if I want to delete the configuration which I have configured on my device, the command is erase startup -config. You can also delete running configuration. You can type erase running sorry, you cannot delete running configuration. Sorry, running configuration is currently running, right? It is there running, because of which only my device is running. So we cannot delete. It will go up actually. So I can type erase startup configuration and I can delete whatever is there in the NVRAM. RAM things you cannot delete it because of that only it is running. Let's learn some commands. Write down these two commands. Enable password Cisco 123. Enable secret Cisco 123. Okay. So let me show you a small lab now. We'll open a packet tracer. I'll take a router. There are three modes in CLI, right? What are those three modes? Enable mode, user mode, then user mode, enable mode, and configure terminal mode. Okay. So let me just take one 1841 router. Click on this, go to CLI, and it will gonna ask you a question, yes or no. What you will type? No. So I typed enable, configure terminal. Then I'm going to configure IP address. Let me just take interface FA 0/0 IP address 10.001.255.0.0.0. No shutdown. I type this command. Now, if I see the running configuration, how do I see running configuration? The command is show running -config. I enter. This is going to display a lot of information here, which I don't even typed. These are all default informations. Don't worry that I didn't even type. But here you can see the information which you entered, the IP address 10.001.255.0.0.0. This is my currently running configuration. There is something called startup configuration also. The command is show startup-config. If I type show startup-config and I hit enter, it will show nothing. Why? Because it is almost like opening a notepad and typing something. This is a running configuration. If I don't save it, without even saving it, if I go to my D drive, can I see this notepad? Can I even find the notepad if I don't save it? No. Same way. Only if you put Control S and save this in a particular place, then only you can see, right? Similar way, startup configuration. So you have to save your running config to startup configuration. For that, the command is copy running hyphen config. Sorry, copy running config hyphen startup config. So I'm copying the running configuration to startup configuration. So we are moving that. That's how it is going to work. Enter. It is asking destination file name. Shall I take, if you see anything in square bracket, right? Means it is telling I am going to take this name as default name. Are you okay with it? I'm okay with it. So I hit enter. If you want to change, that name, you type something in the front. Type something and you can press enter. Now I can see show startup configuration. Now this will display. Before when I typed startup config, it was not showing anything. But here, now it is showing everything. Correct? So now startup configuration also has the same IP address. Now let's see one small command. So EN, if you type and hit tab on the keyboard, this will auto complete that command. If I type EN tab, enable automatically come, enter. CONF tab configure, TR tab terminal. So these things will come automatically. You don't need to even worry about it. Okay. So if you forgot the command, try entering tab. For example, I go inside interface, FA0/0. I forgot the command. What is the command to type IP address itself? So directly put a question mark here. This will tell me what are the possible commands which can be entered inside interface configuration mode. It will show everything. Here, by seeing this command, you remember, okay, the command was started with IP. Okay, IP space. Then I forgot the next command also. I just remember something, but I forgot. Word, question mark. Which is that address command? Here it is. Correct, IP address. So I can type IP address. Then you can type the IP address and all. And on the keyboard, if you press back button, it is going to go back. It is forward. To see old command, up arrow. To see new command, down arrow. Okay. Now exit. I came back, exit. Let's go back to user mode. Let's understand there is a command called reload, and there are certain commands which works only on enable mode, and that can be a problematic command also. For example, there is a command called reload. If I type reload in user mode, it will not work. It will say wrong command. Now what it is doing? It says translating reload something. It is saying it is thinking reload as a command which has some other meaning. It is trying to translate that meaning. Like when you go to Google and type ID website, automatically that website name will change and go some other website, right? Correct. Similar way, we are typing reload. My Cisco this device checking. Is there any alternative command is trying to type? Or else is there any mapping he has done? Reload to that command, some other command. So just try to translate for 3 minutes. Okay. To fast forward, I press here to fast forward time. Okay. Now this reload command, if I go to enable mode and if I type reload, this will reload the entire device. Think about this router. If you have enable access, one router is there, behind the router have hundreds of PCs, and you by mistake type this command reload. So what will happen? The entire PCs will not be able to go online. So it's a dangerous command. So there are certain commands which can affect my Cisco router, and they run only on the enable mode. So this enable mode is, we have to keep it secure. See, user mode, you can give access to anyone, no problem, because only they can see the reception area, nothing. But inside, if they come, then that's a problem. So enable mode, only authorized person should go, not unauthorized person. Everyone can have user mode command, no problem. But enable mode command, only authorized person. So what I can do? We can do something called enable password, meaning anyone typing the command enable, I want him to ask for a password. Simple. Let's do that. I go back to configure terminal. This is short. I can type confd also. Enter. Enable password. I will type Cisco123. That's all. This is a command to configure a password for enable mode. Exit, exit. Now if I type enable, ask for a password. So here it will not show any fancy symbols and all, just for security reason. But when I'm typing something, it is taking inside. Now I can work with it. But the problem with the enable password is that if you type show running configuration now, here the password is clearly visible. Means anybody just for some times if they got access, they know the password. It's a dangerous thing. So that's why we try to use enable secret. Enable secret means password plus encryption. So you just type configure terminal. Let's remove this first. To remove anything which you have configured, the command will be no enable password. Just password. Sorry. You don't need to give this variable. Only type no enable password. That will go off. If I come back, exit and show running configuration, I don't see that here anywhere. Lost. Now let's use enable secret. Configure terminal. Enable secret Cisco 123. Enter. I come back, exit, show running config. Now what happened? This is completely encrypted. So because it's encrypted, it is easy for me to, if nobody able to crack the password. So that's the main difference between enable secret, enable password. Now also same. So if you type enable, that's for a password. Understood? Enable secret, enable password, which is more secure now. Secret is more secure, correct? This is all about your enable secret, enable password. Let's talk about command called telnet. So yesterday I told you about secure shell. Sorry, there are three methods of accessing a device. One is called using console cable, secure shell, and telnet. There are three methods. We learn about telnet now. So telnet is used whenever device is remotely located. For example, I am sitting in Bangalore, my router is in Hyderabad or somewhere else. So via internet only I can reach my device. So if you want to reach a device over the internet, you have to enable something called telnet. Telnet is a configuration using which this guy and this guy can communicate. Imagine that you are from Bangalore and you talk only Kannada, and there is a guy in Hyderabad. If you want to communicate with him, either both of you guys should learn common language, right? Like that, we have telnet. So only if you configure telnet, my device can talk to him. Now, how do I configure telnet? It's very easy. Go to configure mode on router and type line VTY 024. Lion, virtual, teletype. 0 to 4 defines 0th user, first user, second user, third user, and fourth user. Meaning, see, when the device is next to you, using one single cable you connect. In that case, only your laptop is communicating with that router. When the router is somewhere in the internet, lot of people can access it, right, at the same time. So how do I control? Using this number only. 0 to 4 means only 5 users can log in at a given point of time. Secondly, password Cisco 123. See, when the device is remotely located, you should have configure password also. If you don't have password, anybody who knows the IP address, they can log in. Na? That's a dangerous again. So we have to configure password Cisco 123. This I am doing inside what? Lion configuration mode. See, before this hash symbol, clearly see where you are currently. Without seeing this, if you type anything, it will not work. So when I am typing Lion BTY 024, I am going to the Lion configuration mode. Then I am typing the command, Lion configuration. Let's do this now. Configure terminal, Lion VTY 024, password Cisco 123. That's it. Simple. Now telnet is enabled now. How do I verify? I'll simply use a PC for the connection. So here I'm going to go and I'll configure IP address as 10.00.10, 10.001. This IP is 10.001. So my default gateway is 10.001. For example, the doors IP is 10.001. Your IP 10.0010, 10.0020. So door IP is 10.001. That will be your default gateway. Simple. I'll click on this close. First, I will verify whether the ping is working or not. To my default gateway, ping is working. I see a reply from, meaning the ping is working. So I go ahead and go to a place called this and type here 10.001 and telnet. And I click on connect. Asking for a password, Cisco 123. That's it. Now from my PC 0, I reached where? I reached my router. So that's how you configure the telnet. Okay, cool. You understood what is telnet? Now, if you carefully watched, I used only one password, meaning anyone who is trying to access through my device over telnet is going to ask same password to everyone. If you have 50 people and all 50 people use same password, then in the router, how will you decide who configured at what time. We don't know. Anybody can configure, do whatever they want, they leave without even our notice. So it is safe to have individual username and password for each and every employees. So that in case they are doing some mistake in my router, I can identify that mistake. But here, instead of typing password Cisco123, you type login local command. So you type line BTY 024, then login local. When you say login local, you should have configured the username and password in the configuration mode itself. This can be used commonly. That's why it's in config mode. So in config mode, you type username, password, username, password, username, password. Then go inside line BTY 024 and type your thing called login local. So that it is going to ask for a local username and password. Now write this down commands. This command you write it. First step. Okay. Regarding AAA, we'll see later in the volume 2 only, not here. So let's go with the next section. We already talked about how switch forward the frame on day one itself. So let's see some basic introduction. So normally when someone says a LAN, local area network, local area network means what? Connecting two or more devices locally in a single room or single building. In terms of enterprise network, LAN is used to connect your PCs or laptop to their own servers in the office itself. It can be an FTP server, it can be a DHCP server, it can be even an application server. So that's how we use. This is called your switches. This diagram is a person's server. This is your PC. Okay. Now we know about MAC address already, the basic idea. So imagine that in a PC to another PC, I'm sending a packet. Okay. When I'm sending packet from one PC to other PC, I'm going to attach source MAC and destination MAC on top of it. So imagine that you are sending a mobile phone parcel to your friend. Will I be writing my address and to address and from address on top of my mobile phone and put in the letter box? No. We have to take a box. In that box, I'll keep my mobile phone. Let's take a parcel. We have to make a parcel, right? So like this, you can create a gift box or something before sending it out to your friends. Similar way, when I'm adding the source MAC address and destination MAC address on top of the data which is being sent from here to here, we are adding some more additional things also in that. Apart from source MAC and destination MAC, we are adding something called preamble. Preamble means what? See, in a switcher, when a lot of informations are coming inside, so they come by block like this. This one block is equal to this entire box. This is one block. Again, entire box. One more block. The entire box. So there must be an insulation between them, right? To understand these blocks separately, there must be a small insulation. Preamble act like an insulation. Okay? Insulation between the headers. This is called header. Ethernet frame or one header. SFD, start of frame delimiter. See this entire information, which is most important details I need. I need destination address, right? That's what the important thing to deliver that packet. So SFD is kind of an alert message. So they go like this. First preamble goes inside. Then SFD comes backside. SFD is to alert my switch saying, hey switch, behind me, destination MAC address is coming, so be ready. SFD is going to inform him that behind me, he is coming, so be ready with it. So that's called your SFD, start of frame delimiter. Then we got destination MAC address, source MAC address. Type means what? See, on top of MAC address, I am going to have IP address. So we have to inform that device. What is my upper layer protocol? Is it IPv4 or IPv6? That is called type. That tells me who is my upper layer protocol. Is IPv4 or v6? Then you got data and pad. Data means what? Actual data, which I'm going to say like mobile phone. What is padding? Pad means padding. P-A-D-D-I-N-G. What is padding means in English? English. When you send a parcel, you keep that soft materials right around that package so that it won't shake, it won't break. That waste paper, the thermocol, something you waste, you put na paper, cloth and all. That's called padding. See, the size of this entire size is 1500 bytes. What if my data is only 1000 bytes? Remaining information I should fill with padding, or else somebody else will put their own data on. It's dangerous. So padding extra materials. Then FCS, frame check sequence. FCS is used to find out my data which is being sent over the network is not altered anywhere. How it is checked? So the PC1 is going to use an algorithm to run on top of the header which I am sending. It finds out a value. So maybe 0x81. If found out a value 0x81. The data will, the entire header will go here. Again, PC2 will apply same algorithm on top of header, will find out a value. If the find out value is 0x81, he will accept it. If what he got is something else means he will reject it, thinking header has been altered or changed. That's for safety purpose. For example, from here I'm giving you 1 kg of apple. I measure 1 kg. Then also it is inside apple only box. I give it to you. What if someone removed one apple and put orange? It's 1 kg only, but you got one orange in that. So how do you verify it? Just open thing, everything verify. Same way use FCS. Frame check sequence. To check the frame, whether it is correct or somebody altered it. For that we use FCS. Draw this alone. Measure trans number also. This defines how many byte is the size. 6 byte, 6 byte, 2 byte, 4 byte, 7 byte, and 1 byte size. Size of that block. So these places, like you cannot put preamble here, you cannot put destination address here and all. We cannot exchange these things. It's almost like a cupboard. You cannot put your, you cannot hang your shirts here, right? Or you cannot put your shoes on the top. So it's always this place is given permanently for them. So while answering this question also, you have to tell like preamble, SFD, destination, MAC, source MAC, SFD, like that. You have to tell in order only. You should not shuffle them. You know already what is this packet, we learned already. Let's see layer 2 loops and spanning tree protocol. See, in switching, there is a broadcast logic. The broadcast logic of a switch says if a switch receives a broadcast packet, I will forward the broadcast packet out of all available ports except the port I received it. That's what switch says. Because of which this can cause a loop. Let's see how. Imagine that Bob has sent a broadcast packet. This comes all the way to port number 5. This will go out of port number 6 and port number 4 also. Let's follow port number 6. This goes all the way to 7, comes out of 8 as well as 9. This will come out of 1 as well as 2. This will comes out of 5 as well as 6. What happens now? Loop has been occurred. Because for this switch, the packet came from him, not from him. So it will go like this. Loop will occur. Similar way, this ulta loop will occur. So if you have any switches connected in this format, this will cause a loop. Similar with this guy. So if I send a packet here, this will come out of both the ports, right? If you follow this, it goes inside. This will come out of him as well as him, right? This will cause what? Loop. Same way, ulta loop. So this causes a loop. This is called layer 2 loops. Now, any idea how to fix this layer 2 loop? Very simple. You disconnect one cable, that's all. Here also disconnect this cable, finished. If another cable fails, you fix it again. But temporarily, you disconnect one cable to avoid a loop. So it's very simple. But the problem here is, you disconnect this cable, loop is not occurring, all good. Suddenly, this cable failed. Then a person has to rush to data center. He has to run and find out the cable, and again he has to fix the cable. That will take long time. Correct. So there is no possibility of redundancy if I do that. Redundancy means if one cable fails, automatically other cable will take care of the traffic. So if you do manually this thing, it's quite hard for us to maintain the network. That is why we have something called spanning tree protocol. What is spanning tree means? Spanning tree means think like a tree, which is span very big. Okay. So the reason why this might be the reason, I'm guessing it out. I'm not seeing it officially. See, when you take a tree, right? There is a stem that comes now. The stems and all. Have you ever seen a tree stem coming like this? No, it always goes straight. What if a tree stem comes like this? Then what happens? It will stuck. It will stop growing itself. What if a tree which has to grow in a height, if it is goes like this way, can it grow further? No. Meaning, similar way, if a loop occurs, the entire network will be blocked. Nobody can send traffic because imagine a traffic road. There is a road like this. Roads are, people are coming, vehicles are moving like this way. Cars are moving both the ways. What if a loop occurs here? Only certain amount of car will revolve. After some time, no car can come in, no car can go out. Entirely choked. That's what's happening here also. Now, how STP is helping us in avoiding these scenarios, we'll see it in the STP session. We'll take a 5 minutes of break now. Okay, so far if you have any doubt, you can ask me. Or else after break, we'll go with the spanning tree protocol class. Any question you have? So let's see what is spanning tree protocol. It's one of the easiest chapter we have in switching, so very easy. So spanning tree protocol allows Ethernet LANs to have a redundant link, means two links without any loops. And STP is a comes under 802.1D standard. Now what is 802.1D? It's very simple. STP is a protocol. See here, it's a protocol, right? IP protocol. So like if I take this pen, my pen has a model number, correct? This chair has a model number, table has a model number, even this wire will have a model number, right? If you call the service center, if you tell I'm using a this C-type cable, it's not working. They'll ask which model is that. Even though you tell is C-type cable, because they will have thousands of models like this. Similar way, imagine 802.1D is like the model number of STP. An advanced version of STP is called Rapid Spanning Tree Protocol, whose model is 802.1W. Now, if I ask you what is 802.1D, you can explain about spanning tree protocol, STP. Both are same, right? If I say this wire model number and ask you what is that, you can talk about this wire, simple, same way. So if I ask you, can you explain STP is equivalent to, I'm saying, can you explain 802.1D? Both are same. Now, what is the need of spanning tree protocol? You already understood that to avoid layer 2 loops, I'm going to have STP. How it is avoiding, we'll see now. Before we see that, let's understand what is MAC table instability. See, the switches have MAC address table, right? We already know that. So they have something called MAC address table. In that MAC address table, I'm going to have a port number and source MAC address. Imagine that Larry is sending a packet. In FA11, I'm going to have which MAC address on port number FA11? Larry's MAC address, right? It will be Larry MAC address, which I'm going to save. The same packet comes all the way to GI0/1. This will show which MAC address? Larry's MAC address. Same goes all the way here. GI0/1 will have which MAC address? Larry MAC address. Because source MAC alone they will save everywhere. So this comes all the way here. Larry MAC address stored here. Now this comes back here. See, initially on FA0/11, we stored whose MAC address? Larry MAC address, right? Source MAC. And the packet came all the way here. GI0/1 will say Larry MAC address, right? So what happens? Same MAC is learned here and here also. If somebody is giving a packet to him, telling him you give it to Larry, this switch will send out of whom? This side or this side? You don't know. That's called your MAC address table instability. Imagine that we are three people here. Okay. I give this pen to you. You understood that this pen was given by me. Okay. You gave it to her and she gave it to me. Again, I give it to her, you. In between, we have fourth person. We have one more person. And if I give it through him also, this keep on rotating. Sometimes you understand the packet is given by me, sometimes given by him. If you have a, so we are sitting like this. I am sitting here, you are sitting there. There is one more person sitting over here and here also. We are connected like this. Imagine. So I sent a broadcast to you, to him also. This via him, you also received this pen through him. Through me also you received this information. If somebody want to ask you from whom you got the pen, you will be confused whether him or him, whether him or me, because same address you are learning from two people. Then where is he? I don't know. Is he this side or that side? It's confusing totally. So to avoid that also, we are using spanning tree protocol. Let's understand how it works now. See, spanning tree protocol works in 4 different stages. starting with the first stage, which will be root switch. Finding out the or electing the root switch. That will be the first step of your spanning tree protocol. How do I elect a root switch? Very simple. Based on the best bridge ID, or I can say lowest bridge ID. If I say lowest bridge ID, which means it consists of priority and MAC address. See, the bridge ID size is 8 bytes. Priority is how many bytes? That is no. Priority is 2 byte and MAC address how many bytes? 6 byte. That's how we became 8 byte, right? 8 is equal to 2 plus 6. So when I say I'm going to have this best bridge ID, best means whichever switch has the lowest bridge ID is best. So lowest bridge ID means lowest priority and lowest MAC address. If priority is high, then we'll go with the lowest MAC address. Imagine his priority is 10, his priority is 20, his priority is 30. Which is having lowest priority? So he becomes a root switch. Imagine he is also 10. If both are tie, then you go with the MAC address. Imagine his MAC address starting with 0011. 0011. His MAC address starting with 0111. His MAC starting with 0211. Who is having lowest MAC address starting with 0011? So based on that, he becomes the root switch. Simple, lowest bridge ID. Second will be electing the root port. So we decided that he is the root switch. To find out the root port is a port with the lowest cost to reach the root switch. See, from here and here, these are all non-root switches. Imagine this link cost is 5, link cost is 5, link cost is 5. By default, all the non-root switches should maintain a shortest path connection to the root switch. Now, switch 2 is connected to root switch via two-way. One path, second path. Which is the shortest path? Is it through port number 1 or port number 2? Port number 1, because if it's go via it's 5. So this becomes a root port then. Simple. How about switch 3? Which is the lowest one, 4 or 3? Okay. Through him it's shortest or through him it is shortest? 4. It becomes root port. Simple. Do I need a port on switch 1 to reach myself? No, because I am the root switch. Then why do I need a port to reach myself? I will not have a root port. Now you understood root switch, root port, root port. Third one is designated port. Designated port means is a port which is connected to the downstream switches, downstream side, on the bottom side. So you can say all other ports are DP ports. Except the root port, all other ports are DP ports or designated port. Now when I say this, is it clear? Root switch, root port, DP port. Then you got blocking the necessary port. If you find any neighboring port as DP port, then that is the link which is causing loop. If you see carefully, here it is RPDP, no problem. Here it is RPDP, no problem. But here we have DP. So that's a problem. This link is creating the problem. Now how do I block? Which port should I block? This port is port. Again we check the lowest bridge ID. Imagine his bridge ID is 20. I mean priority is 20. His priority is 30. Who is having the best bridge ID? 20 is best. So 20 will tell the 30 that hey, I am having the best bridge ID. So you block your port. Understood? He will not do export. He is the best guy. So become blocking port. So that's a simple process STP is doing. And this all process happens automatically. You don't need to even write any command. So I'll show you a simple lab now. You take like one switch, two switch, three switches and connect them using cable. See, automatically this guy will come. Automatically, everyone will go green color except one guy. Well, that one guy alone will be in orange color because that will be in blocking stage. Now you see that FA0/1 became blocking code. Now how do I verify which is blocking, which is forwarding, which is root switch? The simple command is show spanning tree. So you go to CLI and type one simple command. Go to enable mode and type show spanning hyphen tree. Put enter. This will give you a lot of information. This gives you root ID, which is root switch information. Whichever is root switch, this will be same. If you see here, EA60, right? Root switch will go, only one guy will be root switch in one network, one switching network. So see here, root switch is who? EA60 na. If I go to here and if I go to another switch and type the same command, here also it will show EA60 only. Show spanning tree. Same. You see here also I will go. Same. Now, how do I verify who is the root switch? See, here I am seeing the information about my switch. I mean switch 2. On top, I am seeing information about the root switch. In which switch these both are same means that's a root switch, right? My MAC address and root switch MAC address if it is same, then I am the root switch, correct? If you see here, what is my MAC address? Ending with B7E9, but root switch is EF0. Then switch 0 is not the root switch. Switch 1 is it same? No, I am not the root switch. Then here, is it same? Then he is the root switch. There's one more proof also, see. Okay, easy. So that's how we verify. One simple command, show spanning tree. It also gives you which port is in forwarding and blocking. Here you can see both are forwarding stage, no problem. Here in this switch 1, FA0/1 should be blocking port, right? If I go here, see here, FA0/1 is what port? Blocking. Other one is green color, forwarding. You can also verify like this. Show spanning tree. Understood? Write on this command alone. Show spanning tree. Okay. So this is clear now. Now let's talk about something called BPDU. So imagine that you are a switch and you are a switch. Your priority is 20. Your priority is 30. Now I have the cable is going on between you two. Now tell me who will become root switch. Why? Why not you? Lowest. But how do you know that this switch is having lowest? Who told you that? There must be some packet which should go and tell and compare, right? Without you telling your switch priority, how does she come to know about a priority? Without you telling your priority, how did she decided that he is the lowest? There must be a special packet which is taking this information going, right? That is called BPDU, Bridge Protocol Data Unit. A BPDU is useful to compare the values and to identify who becomes the root switch. Also, BPDU has something called hello BPDU. Hello BPDU means for you to maintain that root power. What if I come in between? Your priority is 10. What if I come in between and sit saying my priority is 5? So I should become a root switch, right? So you should keep on informing every 2 seconds once the root switch will send out a hello packet to the downstream switches saying this information. So the root switch will send out hello BPDU every 2 seconds once. See, initially BPDU was used to compare and decide who becomes the root switch. First task is over. Second task, root switch will keep on sending, it's like a heartbeat. 2 seconds once, hello BPDU, informing these four informations. What information? First information is root bridge ID. Imagine my bridge ID is X. And this is bridge ID is A, bridge ID is B, bridge ID is C, bridge ID is D. Example I'm giving. So hello BPDU will carry the root bridge ID. So root bridge ID will be what? X, right? I'm the root bridge. Sender bridge ID. Who is sending the hello packet? X, right? X. Sender root cost. SRC. What is the cost of switch C reaching switch C? 0. I am the root switch, right? So why there should be a cost of reaching myself? 0. This comes all the way here. Imagine this ring cost is all 5. 5, 5, 5, 5 everywhere. This hello comes all the way here. This hello goes here also through him. When the hello goes from B to A, what will be the root switch information? Root bridge ID will be same, right? X. Because that will not change. Sender bridge ID, A. Who is sending it? A is sending it, right? A. Sender root cost. What is cost of me reaching 5? C. 5, right? 5. Understood? So when this goes all the way down, 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 down everywhere, this will not change because he's same. But who is forwarding that hello, that guy will keep on changing the sender bridge ID and sender root cost. Okay. Now I understood what will change, what will not change. Root bridge ID will not change. Sender root cost, sender bridge ID, sender root cost will change. We have timer value also. Timer value is like hello timer is 2 seconds, max age timer is 20 seconds, forward timer is 15 seconds. The timer value. Okay. And by default in Cisco switches, default priority is 3 to 768. I told priority 10, 20, 30 and all right. By default, it will be 3 to 768. If you want to change it, you can change it. That's totally fine. So in my diagram also, if I choose here, what's the priority value? Here it is 3 to 768. That's a default priority. By default, it is that. If you want to change, you can change, no problem. It's small. The output I already showed you, right? The shows final tree output is here. Same output mentioned here. Huh? Which value? 3 to 7, 6. Huh? And that is constant. These timers are constant. 2 seconds, max size time 20 seconds, forward time 50 seconds. Here also you can see the same. Same, right? Hmm.
ஷிஃப்ட் மாறி மாறி வரதுனால என்னால ஜாயின் பண்ண முடியல.